Oops. Okay, so hi guys. We're going to talk a little bit more about section 11.3, which was the dot product. So just remember, if you have vectors u and v, the dot product is a scalar u dot v, and you get it by multiplying the components u1 v1 plus u2 v2 plus u3 v3. So you can use this to find the angle between two vectors. So here's v and u, and theta is the angle between them when they meet at the origin. And so the formula is cosine of theta is u dot v times the magnitude of u, over the magnitude of u times the magnitude of v. If we know theta, we can use this to find the dot product just by rearranging the equation, right? So u dot v is the magnitude of u times the magnitude of v times cosine of theta. All right. So if two angles meet at a right angle, so 90 degrees, then we say that the two angles are orthogonal. So there's a picture, they meet at a right angle. A right angle is 90 degrees. So what does that mean about the dot product? Well, the dot product is the magnitude of u, magnitude of v, cosine of 90, which is 0, because cosine of 90 is 0. So we get this fact, u and v are orthogonal if and only if u dot v is 0. So we have an easy way to check whether two vectors are orthogonal. So for example, let's decide if the vectors 2, 18 and 3 halves, negative 1/6 are orthogonal, parallel, or neither. So remember, to be parallel, the vectors have to be a scalar multiple of each other. So is there a scalar that you can multiply v by to get u? Well, no, there's not. There's no way to do that, so they're not parallel. So the next thing we want to check is whether or not they're orthogonal, and you just take the dot product. So 2 times 3 halves plus 18 times negative 1/6 is 3 minus 3, which is 0, so u is orthogonal to v. Let's look at another example. So here are several vectors. U is 3, negative 1, 2. V is negative 4, 0, 2. W is 1, negative 1, 2. And Z is 2, 0, negative 1. So let's find the following angles. So between U and V, so we're just going to use the formula. Cosine of theta is u dot v over the magnitude of u times the magnitude of v. So if you plug in, you get negative 12 plus 0 plus 4 over magnitude of u, magnitude of v. That's negative 8 over square root of 14, square root of 20. So theta is cosine inverse of that, which is 2.069 radians. Alright, let's try another one. Angle between u and w. Again, cosine of theta is the dot product of uw over the magnitude of u times the magnitude of w, and so we get theta is 0.5097 radians. Alright, last one. What about the angle between v and z? So remember, v is, negative 4, 0, 2. Z is 2, 0, negative 1. So notice, what do you notice about v and z? We've got negative 4 and 2 in the first components, 0 and 0, and then 2 and negative 1. So v is negative 2 times z. So what does that mean about the two vectors? That means that they're parallel. Okay, they're not only parallel, but since v is a negative multiple of z, they're parallel in opposite directions. Right? So if you have two vectors that are parallel in opposite directions, what does that mean about the angle between them. So if this were V and this were Z, the angle between them is going to be pi, 180 degrees. So without even, whoops, so I drew it again. Without even calculating the dot product, we could determine this. You should go ahead and try this using the formula too. Alright, the last thing I want to talk about from this section is the projection of u onto v. So given two non-zero vectors u and v, we want to imagine taking another vector parallel to v, sort of above u. So let's see, something like this. And shining a light from that vector onto v. What would the shadow of u look like on v? That's the projection of u onto v. Okay. The formula for this is u dot v over the magnitude of v squared times v. So you can see this is clearly in the direction of v. Now if I rewrite this, what I have here is the unit vector in the direction of v times a scalar. And again, if you know if you know the angle between the two, we can use the formula for the dot product to rewrite that. So this is called the component of u, and that should be the magnitude of u cosine of theta. Component of u in the direction of v. Okay. So our vector u can be written as the sum of two vectors w1 plus w2, satisfying that w1 is parallel to v and w2 is orthogonal to v. So we just said that we know a vector that's parallel to v, the projection of u onto v, and then we can solve for w2 by just taking u minus w1. Okay, this is called the vector component of u orthogonal to v. Alright, let's look at an example. Let's find the projection of u onto v and the vector component of u orthogonal to v for the following vectors. Alright, so 2i plus 3j and 5i plus j. Alright, so we just plug into the formula. So I've rewritten u and v here in component form. Projection of u in the direction of v is u dot v over magnitude of v squared times v. So u dot v is 10 plus 3. Magnitude of v squared was 25 plus 1. So that gives you 5 halves, 1 half. Now w1 is going to be the projection, so w2 is just u minus w1, which gives us negative 1 half, 5 halves. Okay, so what do we have here? Oops, sorry. Sure. So this is parallel to v, and this should be orthogonal to v. So these are vectors in the plane, so let's draw them. Alright, so we've got 2, 3 is u, 5, 1 is v, 5 halves, 1 half is the projection, and negative 1 half, 5 halves is the component orthogonal to v. So here's my x-axis. Here's u and v. There's the projection of u onto v. And there's the vector component orthogonal to v. Alright, so remember w1 was 5 halves, 1 half. W2 is negative 1/2, 5/2. Alright? And it's clear that, again, if I were to shine a shadow here, this would give me W1. Also, remember, when we take the sum of two vectors, we take W1 and we would draw W2 at the end of W1. Let me use purple. So this is W2. And the sum of W1, W2 is exactly U. Alright, so please read the section. There's a few things that we didn't cover in here. Please read those over, and if you have questions, you can email me with your questions, or you can ask Dr. Poet with your questions. Work on the homework and in WebWork and in the book. And again, please contact me if you have any questions. I will see you in class next week, and have a good week.